Okay, this is problem 18 on April 9th. Local linearization problem. Good question. Pretty important type question. Could show up for sure on a FRQ. The question was, the function evaluated at 5 is equal to 3. The derivative of 5 is equal to 4. Let's find f of 4.8 using local linearization at x equals 5. Two ways to do this. I think the safest way is just to remember local linearization means tangent line. I don't think I did it this way originally. I use local linearization. Local linearization is, if you start with y equals f of x, then dy equals f prime of x dx. So I'll do this both ways, but local linearization just means find the tangent line. So let's find the tangent line at x equals 5. So at x equals 5, I have the point, which is 5, 3, and I also have the slope, which is 4. So the tangent line becomes y minus 3 equals the slope, which is 4 times x minus 5. Y equals 4x, I got a minus 20, plus a 3 minus 17. So now we're just going to estimate 4.8. So 4 times, 4.8 minus 17. Let me whip that out on my calculator real quick. 4 times 4.8 minus 17 is 2.2. The other way is just use the differentials. dy equals f prime of x dx. So dy is change in y. This is actually using local linearization this way. This is just tangent line, but it's the same thing. Dy is change in y, so we're going to find that. It's the derivative at 5, which is 4, times the change in x. We're going from 5 to 4.8, so that's a negative 0.2. So that means my change in y is negative 0.8. That's how much y changed. So now we want to know, that's how much y changed when x went from 5 to 4.8. So now y, the original y was 3. So now I want to just take that 3, and this is my change in y, which is the negative 0.8. Gives me that same 2.2. Two ways to do that same problem. Local linearization means the same thing as tangent line. So if you struggle with local linearization or differentials, tangent line is the way to go.